Let's discuss exercise 6b, question number 1. X follow the binomial distribution 8 and 1 over third. N equal 8, x equal p equal 1 over third. Then p x equal x is ncx px 1 minus p n minus x. Then x is we'll substitute p x equal x is nc n is 8, 8c x p is 1 over third x and 1 minus 1 over third 8 minus x. So the x equal x is 8cx 1 over third x and 2 over third 8 minus x. So question number A, probability of x equal to. So we'll put simple x equal to here. So probability x equal to is 8c2 1 over third 2 and 2 over third 8 minus 2, which is 8c2 1 over third and 2 over 8 minus 2 is 6. So you can work out this one. I can see there are two parts, x equal 5 and x equal 1 less or equal to 1. So you can use you can work from the calculator one by one, or from that 7 and then 4 and 1, and then you have to write 0 to 8 and you can get straight away everything. Or it's up to you, your calculation you can do. So you will get answer 0.273. And part B, probability of x equal 5. Then p x equal 5 is 8c. Instead of x I put 5, so 8c5 1 over third 5 and 2 over third. This has to be addition to add, so then this value has to be 3. But if you follow this one, 8 minus 5. So 8c5 is 1 over third 5, 2 over third 3. And this value has to be 0.66x683 approximately. Probability of x less than or equal to 1, which is probability of, so when you take number line 0 and 1, so 1 and 0 both you need for the calculation. X equals 0 plus probability of x equal 1. So this is going to be 8c0 1 over third 0 and 2 over third 8 minus 0 is 8. Or you know that the addition has to be 8. And this is 8c1 1 over third 8 1, and this is 2 over third 8 minus 1 is 7. So this is 1 third also 1. This is 2 over third 8 plus 8 times 1 over third times 2737. So our answer should be one more calculation 2838 plus 8 times 2738. This is become then 28 plus 8 times 2s over 3 to the power 8. So approximately 0.195. Question number 2. So T follow the distribution, binomial distribution 15 2 over 3. So n value is 15 and p value is 2 over 3. So 1 over p is 1 minus 2 over 3, 1 over third. Probably p t equal t is follow in c t pt 1 minus p n minus t, because when it is t, instead of x I will replace t now. um, p t t equal n mean 15 ct, p is 2 third t and 1 minus p is 1 third, 15 minus t. Now the first question is when e equal a t equal 5, and then probability of t equal 5 is 15 c5 2 third 5 and 1 third, 15 minus 5 10, or your addition has to be 10. So this value is going to be 0.0067 approximately. And part B, when t equal 10, it is the t equal 10 probability 15c10 2 to the power 10 1 to the power 5, 10 plus 5 15. So this is approximate value 0.214. And part C is probability of 3 greater than or equal to t greater than 4. It means probability of x equal 3, t equal 3 plus probability of t equal 4. Now this is probability of t equal 3. We'll write straight 15c3. So this is 2 over 3 to the power 3. Then 1 over 3 has to be 15 minus 3, 12. And 15c4 is 2 over 3, 4, and 1 over third, 15 minus 4, 11. So the addition of this one approximately 0.0002536 plus 0.001522, and that value is 0.00178. Question number 3. The student suggests using the binomial distribution model the following situations. Give a description of the random variable. State any assumption you made. Give possible values n and p. So the sample of 20 part A sample of 20 balls from a large batch checked for the defects. The production process should produce 1% defective. So we can see now the random variable x is number of defectives balls, number of defectives, number of defective balls. So number of samples 20, so n equal 20. The interest is defective, so our interest is defective. So probability of defective P is 1%, which is 0.01. Now we can write, when we write binomial, we need n and p. Now we have that facilities now. The requirements n is 20, p is we have. Now we can write the distribution. X follow binomial distribution 20 with the probability 0, 1. So the assumption is the defectiveness of one ball not does influence the defective of others. So doesn't influence, it means the balls are balls are defective independently from one another. When you toss a coin, the first toss is totally independent from second toss. The first doesn't influence or independent. So the default the faultiness or defectiveness is totally independent from one another. Balls are defective independently from one another. Part B. About traffic light issue, traffic light problem. A pedestrian. There are 48 minutes stop, 4 minutes get ready, and other 4 go time. It means total 58 to they have go time. So there are 6, 1, 2, 3, 4, 5, 6 lights. When you go through, either you can stop or without any problem you can go. So 0 stops. So the variable is x is number of time stop. Sometime without any problem. Sometime he may stop here and go others, or stop here and go others, and stop here and go others, or stop here and go others, here and go others. There are 1, 2, 3, 4, 5, 6 options like that. So then 1. So this is 1 times, this is 6 times binomial, and likewise then the 2 times stop, this one and this one, or this one and this one, this one and this one likewise. So 1, 6, that is going to be 6c2. What is 6c2? So this is the setup. Factorial 6 over factorial 2 factorial 4, that is going to be 6 times 4 divided by 2, that is 15. So this 3 and 4 like that. So n value is 6. P value is 52% or 0.52. So the distribution is 0.52. The assumption is um, lights operate independently, and uh, on and off is a constant. Part C. The Stephanies plays tennis with Timothy on average of 1 in 8 of a serve in an ace. How many aces? So this, okay, so this is variable x is uh, number of aces. So n equal 30, p is 1/8 of. So the distribution is then 30 1 over 8. So the assumption aces occurs independently. No influence from one another, and the probability is constant or equally likely. Probability of an is constant. Question number 4. State which of the following can be modeled by with the binomial distribution and which cannot be. So question part A is given 15 people have blood that is rhesus negative. The model the number of pupils in the statistics 14. So uh, okay, the probability of who is having rhesus negative is 15%. So P is given 0.15, and we need to do a sample of 14 students. So n equal 14. So then what is the variable? Number of people in class of number of people who are RH negative. Then the binomial distribution is 14 n and p value is 0.5. Now the assumption is for that RH negative, RSS negative is independent from pupil to pupil. So no relations or siblings. So then it's not going to be independent. Part B, you are given a fair coin to toss and told to keep tossing it until you obtain a four-head in succession. Model the number of tosses you need. So fair coin, we know that probability is 0.5 or half 1. But to have a binomial distribution, we should have fixed trials. Now, obtain four heads until we get four heads. Sometimes we get four heads in the first process. 1, 2, 3, 4. First process. Sometimes we don't get any, and this is we may get 14, 15, and then 16, not, and then 20 and 59. So we may get 4 in this one. So likewise, we can see that number of process is not fixed. It means no fixed number of trials. So this is the usually yeah, bit similar to the geometric distribution. So fixed trials. So there there are no fixed number of trials. Hence, this experiment cannot be modeled by binomial distribution. Part C. A certain car manufacturer produced 12% of new cars and red 8% in blue and 15% white, and you may note that the colors of the first 15 cars. So you can read the question, and the red cars, we have to model number of red cars. Red cars, then non-reds. Then the probability is going to be 12%, and non-reds are going to be 78 and 88%. So the red car. So variable is counting number of red cars. Number of red cars. And N is 15 cars. P is 12% or 0.18. And we may get 0, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15. And sometime we may get whole 15 cars. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2. So sometime we don't get not a single car is red. Actually, we can present this experiment by binomial distribution with 15 trials and 0.12 probability. So sometimes we may not a single car. It means 50 C 0. What is the probability? 0.120, and then 0.88 is going to be 15. Not at all, not a single one. Sometimes we may get 4 cars in this 15. the probability of getting 4. So 1, 2, 3, 4. First 4 A may be. Or otherwise, first one and this one, 2, and this one and another one. Or likewise, lot of combinations. So that combination will give 15C, uh, 4. Out of 15, how many combinations we can make? 4. 15C4, and the probability 0.12 to the power 4 and 0.88. 15 minus 4. So likewise, we can model this scenario by binomial distribution. The assumptions are um, colors uh, should be independent, or getting red is not getting red uh, cannot be influenced by other colors. At the same time, getting blue, because it is in a process, getting blue is not influenced by other colors. Getting again white, cast red, blue, and white, and rest are. So any color not influenced by other colors. So colors has to be independent. So yes, the real meaning is color can't influence into other ones, or the system machineries. So this machinery should be picked up randomly. Independent, not influencing each other. Question number 5. The balloon manufacturer claim 95% of balloon will not burst. So 95% are good balloons, and only 5 are defective balloons. 5%. If we have 20 of these balloons, so the sample size is n is 20. These balloons blow up for the birthday. What is the probability that none of them burst or blown? Find the probability that exactly 2 balloon burst. So we can model this experiment by binomial. X is modeled by number of balloons that do not burst. Number of balloons that do not burst, and x, the variable, b, n is 20, and probability is 95% or 0.95. So this is going to be 0.95. We can model this one differently, but instead of number of burst, we can come as, let's say, y variable do not burst. So number of burst, then that probability n equal 20, that probability is uh, only 5%. It means 0.05. Then y is modeled by binomial 20, 0.05. Then the first question they ask, what is the probability that none of them burst? None of them burst. So then we are going to get x equal number of None of them burst. It means all are good. It means x value is good, 20. In terms of here, y value has to be 0. No burst. This is number of bursts, no burst. So both have the same probability if you calculate. You will write and see that. So here no number of bursts, 20, C 20. So 0.95 all are good. 20 and 0.05 is 0. Here 20C0, 0.050, no burst, number of burst, no burst, and 0.95, 20. See that this is there, this is there, there, this is there, this value is 1, this value also 1. So I'll give the answer as a part question A. So this is going to be 1 times 0.9 to the power 320 times 0 power is 1. So 0.9 to the power 20. So this answer should be around 0.358 approximately. So which is the same answer here, 0.358. So find the probability that exactly 2 balloons burst, part B. So then x value is find the probability that exactly 2 balloons burst. So our variable is number of balloons that do not burst. So we have to apply in a do not term. So 2 burst mean how many goods? 18. So then x value has to be so exactly 2 bursts mean exactly 2 bursts mean we need in do not form. Uh, so not burst is 18. So then we need 20C 18 0.95 18 times 0.052. Now with this one is this question exactly match. Find the probability that exactly 2 balloon burst. Exactly 2 balloon burst. So the variable defined for burst, it is also in burst mode. 2 balloon burst. So then this is going to be 20C 2 0.052 and 0.95 80. As a summary, for this variable defined for good ones, do not burst mean good ones. Then always your submission should be good. This variable is upon the burst, bad ones. Then your submission should be here y equal to probability of y equal to. This is probability of x equal 18. Now you can see both same. 0.95 here, 95 here. This is here, this is here. 2018 means factorial 20, factorial 18 and 20 minus 18 factorial 2. 22 to factorial 2 and factorial 2 and 20 minus 8 is factorial 18. Both same. So the answer should be same for both. That is going to be 0.189 approximately, 0.189 approximately. Question number 6. The production department, factory, switch manufacturing. They have the probability of faulty is 0.8, 0.08. So good is then 1 minus 0.08, that is going to be 0.92. Fault is 0. Good is 0.92. And define a suitable model to the fault switch in the sample. For this question, following page number 88, the binomial definition. In first one, there are fixed number of trials. Are there fixed number of trials? Yes, there are fixed number of trials because only 10 samples. Uh, there are fixed number of trials, that is 10. And the second one, there are two possible outcomes. Are there two possible outcomes? Yes, there are two possible outcomes. One is faulty, other one is non-faulty. Then there is a fixed probability of success fee. Is there is a fixed probability of success fee? Yes. There is a fixed probability of the success. Success here means our interest. What is our interest is what is this probability is given? Faulty. There is a fixed probability for success or our interest which is faulty, or our interest, that interest is faulty, which is 0.08. The trials are independent of each other, so we have to assume, if it's not given, so we have to assume that the trials are independent from each other. Switches or samples are independent from each other. Not the member of samples, switches. Number of samples switches are independent from each other. So page 28, so you have to do that checks. Hence, binomial is a suitable model to illustrate. So then binomial variable. So we didn't define the variable. So x number of fault. So x follow binomial 10 0.08. Now for this model only you can put the faulties, number of faulties. If the question asks, okay, find how many 18 goods, so you can't put 18 here, you have to come up with the bags. So number of faulties, 18 good mean faulty is 2, so you have to apply in that way. Part B, we want to find sample contain 4 faulty switches. So a probability of x equal 4. It means when we have 1, 2, 3, 4, 6, 7, 8, 9, 10. So either this one can be fault 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Either another one, this one, and this one, and this one. So likewise, there are set of, what is this set? 10C4. So 10C4. So 0, this is the interest one, 4, and 1 minus p. So the equation is probability of x equal x is 10cx px 1 minus p 10 minus x. So we want to write actually the this one. So pcx 10cx 10 minus x. So n value is 10, p is 0.08. Before write we have to write this one. Let me correct this one. N equal 10, p is 0.08, and then x follow binomial 10 0.08. Then this one pcx 10cx px, this is the standard form, and then when x equal 4, this is the answer. So 1 minus p mean we calculate 9 2. So I think it's better to write in a proper form. So proper work is very important. So probability of x equal x is ncx px 1 minus p n minus x. When n equal 10, p equals 0.08, 1 point is p is 0.92, then p x equal x is n mean 10 cx, p is 0.08 x, and this is 0.92, 10 minus x. So when x equal 4, probability of x equal 4, simple x, 10c4, 0.084, and 0.98, 10 minus 4. So that is 10c4, 0.084, and 0.986. The probability is 0.00522 approximately. Question number 7, part A. A particular genetic marker is present in 4% of the population. State any assumptions that required to model the people with the binomial distribution. Then I'll go to page 88, and I'm starting looking at this one. So you should remember these things without looking page 88. There are fixed number of trials. So the first assumption is there should be fixed number of trials. The second one, there are two possible outcomes. There are two possible outcomes. In here, it is genetic marker present or not present, and there is a fixed probability for success. Yes, it is there. There is a fixed probability for success, that is given 0.44%, which is 0.04, and number of trials are independent of each other. The trials are independent of each other. Now we have to define a variable, uh, number of people who are having or present genetic marker. So sample size n equal 50, p is 0.04, 1 minus p is 0.96, and probability of x equal x is pcx px1 minus p n minus x. So px equal x, sorry, ncx, n is 50 cx, p is 0.04 x, 1 minus p is 0.96, 50 minus x. So now probability of x equals 6 is 50 c6, 0.046, and 0.9c, 50 minus 6. 56, 0.46, 0.96, 44. This answer is 0.0108 approximately. One important thing I didn't write, the uh, distribution. We have to write x follow binomial, uh, 50, 0.04. This is very important thing. You will get marked for this. Question number 8. A die is biased so that the probability is landing on 1 on a 6 is 0.03. So 0 die 15 times n equal 50. State the assumptions. State the distribution as a binomial. As I discussed, page 88 again. Page 88 again. There are fixed number of, there should be a fixed number of trials. So n equal 15 is given, I think. And the other one, there are two possible outcomes. There should be two possible outcomes. So getting 6, so getting 6 or not, or not getting 6. Getting 6. The other one, fix. There is a fixed probability of success. Should be a fixed fixed probability of success. Yeah, we know that probability is given 0.3, and trials are independent. Each role is independent. Now n equal 15, e equals 0.3, hence x follow binomial 15, 0.03. The variable x is number of sixes, 6. And p probability of x equal x is ncx px 1 minus p n minus x. So px equal x, n is 15c x, p is 0.3 x, and 1 minus p, 1 minus p is 0.7, 15 minus x. The question B is find the probability that for exactly 4. Probability of x equal 4 is 15c4, 0.34, and 0.7, 15 minus 4. So 15, 4, 0.34, and 0.7, 11. So this value is going to be 0.2119 approximately. Part C. Find the probability that rolls 2 or fewer. Probability of x less than or equal to 2. It means probability of x equals 0, and probability of x equal 1, and probability of x equal 2. So this is going to be 15c0, 0.3, 0, and 0.7, 15, plus 15c1, 0.31, and 0.7, 15 minus 1, 14, and 15c2, 0.32, and 0.7, 15 minus 2, 13. This value is going to be 0.127. So 15c0 factorial 15, 0, and 15, 15c1. Sometime you better write to get the marks. 15 and 1 and 15 and 15c2 is 52 and 13. 15, 2, and 13, those are the three values. 15, 13, 12, 15, 1, so this is 14. 15, 0, 15.